Hi everybody. Today in this video we shall discuss on previous worksheets which I have uploaded in Electrostatics 1, Electrostatics 2 and Electrostatics 3 videos. So coming to first worksheet, that is properties of charges. Which worksheet I am going to explain first? Properties of charges. In this properties of charges, majority of the students asked only one question, that is question number 24. Question number 24. So I will read out that question once. Check in your worksheet. Which of the following charge cannot be possible? Which of the following charge cannot be possible? This is the question, and there are options like 1.6 into 10 power minus 18 coulomb. Option A is 1.6 into 10 power minus 18 coulomb, and option B is 1.6 into 10 power minus 19 coulomb. Option C 1.6 into 10 power minus 18 coulomb, and option D is none. So in this, which of the following charge cannot be possible? So let us see the solution for this. It's very simple. So we know charge is quantized. Charge is quantized. Already we learned this one. So according to charge is quantized, the formula of charge is Q is equal to Ne, where N is a number, it has the values of 1, 2, 3, etc. So the N value cannot be a fractional number like 5 by 6 or something, or it cannot be exponents of minus powers, and it cannot be fractional decimal values like 2.4, 2.6, etc. These are not possible values. When you calculate N value, if you get these values, then it is not possible charge. So let us see that. First let us take option A. In option A, charge is given, means Q is given. How much? Q is equal to 1.6 into 10 to the power minus 8 coulombs is given. And we need to calculate N now. E value, what is the fundamental charge? Magnitude of fundamental charge is charge on electron or proton, that is 1.6 into 10 power minus 19 coulomb. From this, if I calculate N value, N is equal to Q by E, that is 1.6 into 10 power minus 18 by 1.6 into 10 power minus 19. So that the answer what you are going to get, by simplifying this, you will be getting the N value as 10. So this is possible because N can be integer values 1, 2, 3 and so on. So similarly, B, calculation of B. In B, 1.6 into 10 power minus 19. So that the N value what you are going to get is 1. 1.6 into 10 power minus 19 by 1.6 into 10 power minus 19. C coming to, it is 1.6 into 10 power minus 20. Sorry, it is not 18, 20. So then N value will be 1.6 into 10 to the power minus 20 by 1.6 into 10 power minus 19, E value. So this is, what do you get? Yes, you will get 0.1. So that's why N value cannot be fractional value, decimal value. So that this is not possible. So our answer is what? C. Clear? Very good. Next, on that. Next, coming to second worksheet, that is based on Coulomb's law. Second worksheet is based on Coulomb's law. In that, students asked some of the questions. So in Coulomb's law, the students asked few doubts, sir. They asked question number 16. Question number 16. See that question. I'll read that question once. See that. Two charged objects have a repulsive force of 0.080 newtons. If the charge of one of the object is doubled, then what is the new force? Okay, that is the question. Now see that there are two charges, right? Let us take this is a charge Q1 and another charge Q2, right? So the repulsive force is, this is the force of repulsion between them, that is 0.080 newtons is given in the problem, right? This is the first case. What happened if the charge of one of the object is doubled? I am taking on Q1, it is doubled, so it is 2Q1 and Q2 is same. Then what is the new force? F dash is how much? This is the question they are asking. Okay, so in this case we are not changing the distance between them. It is given that distance is constant. Okay, I am taking as R. Let us see, calculate F first here. What is the formula to calculate F? We know that is 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, here F dash will be how much? 1 by 4 pi epsilon naught 2 Q1 Q2 by R square. Now what I am doing is I am dividing F dash by F. That is I will be getting 1 by 4 pi epsilon naught 2 Q1 Q2 by R square by 1 by 4 pi epsilon naught Q1 Q2 by R square. So here these two gets cancelled, Q1 Q1 Q2 Q2 R square. So that what is the answer? 2. That means F dash is equal to 2F. This is the answer. F dash is equal to 2F. Now F is given in the question, so that F dash will be how much? 2 into 0.080, that is 0.16 Newton is our answer. Okay, right. So next question student asked is question number 19 in the same worksheet. See question number 19. Let me read that question once. So the question given in this is the average distance between the electron and central proton in a hydrogen atom is 5.3 into 10 power minus 12 meter. That means here distance is given. So that distance I am taking as R. It is 5.3 into 10 to the power minus 12 meter is given. What is the magnitude of average electrostatic force between these two particles? So we need to calculate force. So to calculate force we need charge. So here what are the charged particles are given? Electron and proton. So we know that charge on electron, let us take as Q1, that is 1.6 into 10 power minus 19 coulomb. Charge on proton, let us take Q2, that is also 1.6 into 10 power minus 19 coulomb. So now you can solve, I think. So the students confused here, they did not understand what charges Q1, Q2 they must take. So here charge on electron and charge on proton. Now you use the formula to calculate F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So all the values are given and all the values are in SI, so that you can calculate directly. Okay, so that. Next question they asked is question number 21 in the same worksheet, question number 21. So that is two unlike charges separated by a distance of 1 meter attract each other with a force of 10 power 8 Newton. So there are two unlike charges. Let us take this is plus Q1 and this is minus Q2. These are the two unlike charges separated by a distance of 1 meter is given that, and attract each other with a force also given that as 10 to the power 8 Newton here. If the charges are in the ratio 1:3, charges are in the ratio, let us take Q1 and Q2. What is the ratio? 1:3 is given. Then what is the weak charge? Means let us calculate Q1 is how much and Q2 is how much. From this you can write Q2 is equal to 3Q1. Can I write or not? Q2 is equal to 3Q1. Remember this value. Let us say this as equation 1. Okay, now let us go to our formula, basic formula. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here F is given how much? 10 to the power 8 is equal to 1 by 4 pi epsilon naught value. We know that 9 into 10 to the power of 9 into Q1 we don't know, into Q2 we don't know, by R square. R square is 1 square is 1. That's it. Okay. Okay. From this we can calculate Q1 into Q2 value. So how much you are going to get from this? Q1 into Q2 is 1 by 90. 1 by 90. Let us take this as equation 2. Now substitute Q2 value in equation 2. Okay, Q2 value is 3Q1. Then what are you going to get? You will be going to get Q1 into 3Q1. That is 3Q1 square is equal to 1 by 90. So that Q1 square is equal to 1 by 3 into 90. Therefore Q1 value is 1 by, what is that? 3 root 30. 3 root 30 coulombs. Then what about Q2, sir? 1 by root 30 coulombs. Okay, we got Q1 and Q2 values in this way. Right? Okay. Next problem they asked in this same worksheet is question number 24. The question is this: two equal metal balls are charged to 10 microcoulomb and minus 20 microcoulomb. Then they are brought in contact with each other and then separated to their original distances. The ratio of the force between the two balls is what? Okay, so first there are two balls. Let us take this is ball A and this is ball B. Okay, on ball A the charge is 10 microcoulomb and on ball B it is given 20 microcoulomb. They are separated by some distance. Now what happened? They brought contact. See this, A and B brought in contact with each other. Okay, so when two charged bodies brought in contact, what happens is charge transfer will takes place. Charge transfer will takes place. Then how much charge will go from one body to another body? That depends on the volume of the body. That depends on volume of the body. So here given that two equal metal balls, they are given two equal metal balls, so that the volume of the first body and the volume of the second body are same and their material also same. Then the amount of charge transfer will be equal. So what is the net charge first? Net charge in this case is 10 microcoulomb minus 20 microcoulomb, that is minus 10 microcoulomb. This is the net charge. This net charge is going to divide into equally to A and B. That means it is going to divide equally, means on A it is minus 5 microcoulomb. This is on A. and on B is again minus 5 microcoulomb. Now this is the force, new force we need to calculate. Initial force let us take as F. Clear? Now F is what? 1 by 4 pi epsilon naught q1 q2 by r square. Let us take that 1 by 4 pi epsilon naught as constant k. Then 10 into 10 power minus 6 into 20 into 10 power minus 6 by r square. Distance is not given, I am taking as r. Okay, it is microcoulomb, that's why 10 power minus 6 here. Then what about F dash? K into, K is 1 by 4 pi epsilon naught, right? 5 into 10 power minus 6 into 5 into 10 power minus 6 by r square. The distance between them is not changed. Then let us do F dash by F again. Okay, F dash by F. Now see that F dash is K into 25 into 10 power minus 12 by r square by F is K into 200 into 10 power minus 12 by r square. So if you solve this, you will be getting what? 25 by 200, that is 1 by 8. 1 by 8, that is the ratio of the forces is 1:8. So 1:8 is the correct answer. Clear? Remember this one, charge transfer will be taking place here. Okay, that again depends on the volume of the body. If the volumes are equal, equally it is distributing. If the volumes are not equal, what happens, sir? So in the ratio of their volumes, the charge will be transferred. So ratio V1 by V2 will be equal to Q1 by Q2, right? Very good. Next question they asked in the same worksheet is question number 30. Question number 30, 30. Same worksheet. Question number 30. Let us see what is that. 3 charges each equal to 10 power minus 9 coulomb. 3 charges. Let me take Q1 is equal to Q2 is equal to Q3 is equal to 10 power minus 9 coulomb are placed at the corners of equilateral triangle of side 1 meter. Let me draw an equilateral triangle. This is an equilateral triangle of side 1 meter. 1 meter, 1 meter. Okay, then the force on one of the charges is what? The force on one of the charges. Let us take this is A, B, C. At A, I placed Q1, at B, Q2, at C, Q3. I am going to calculate force on Q3, means the charge placed at C. Okay, I am going to calculate net force. Net force means force due to charge Q1 on Q3, force due to charge Q2 on Q3. Let us draw first how in what direction they are acting. Okay, as these two are like charges, they repel each other, so that the force will be acting along the line joining that. So this I will be taking as F13, and similarly Q2 and Q3 repel each other, and the force also acts along the line joining that, F23. The resultant of F23 and F13 is the net force. And what is the angle between them? It will be equal to 60 degrees because it is a equilateral triangle, right? First let us calculate F23, that is 1 by 4 pi epsilon I am taking again constant. Okay, so Q2 into Q3, Q2 into Q3 is, Q2 is how much? 10 power minus 9 into Q3, 10 power minus 9 by r square is 1. So this is K into 10 power minus 18 newtons. This is F23. Similarly F13 also will be same, K into 10 power minus 18 Newton. Okay, now F is nothing but F23 plus F13. So by using vector knowledge, one can calculate magnitude of the net force is equal to root over F23 square plus F13 square plus 2F23 into F13 into cos 60 degrees. Now you substitute the values and simplify that, you will be getting the answer. The answer for that is 9 into 10 power minus 9 into root 3. Okay, that is the answer for that. Just you simplify that. I explain how to calculate that. Clear? Right. And the next question they asked is question number 32. Question number 32. What is that? Let us see. Question number 32 is 3 charges 2q, capital Q and small q are placed in a straight line at point 0, x and 2x respectively. Let us see, this is a straight line. Let us take this is point 0 and this point is at a distance x from the 0 means origin, and another point which is at a distance of 2x from the origin. At origin the charge is 2q is placed, and at x capital Q is placed, and at 2x small q is placed, right? So the net force on q is 0, small q. What is given? F net on small q is 0 is given that. Then what should be the capital Q value? We need to calculate capital Q value. So in this case the net force on small q should be 0 for what value of capital Q? Understood? So that now see that what are the forces acting on small q? So on small q, what are the forces acting? One is force due to 2q, okay, that is away from that. This I am taking as F 2q. This is the force due to 2q, and this q also applies a force on that body, that is also will be in the direction, that I will be taking as Fq. See this, in this situation these two forces are acting in the same direction. Can it be 0? Can the net force will be 0? It's not possible. One should be in the opposite direction. That means the sign of the capital Q should be negative. Okay, let us see that. So it is given that net force is 0. That means Fq should be equal to F2q. Am I correct or not? If the force due to the capital Q and the force due to the 2q is equal, then only the net force is 0. Let us calculate F capital Q. F capital Q is how much? 1 by 4 pi epsilon naught q1 q2 by r square. So I am taking 1 by 4 pi epsilon naught is constant k, q1 is capital Q, q2 is small q, by r square is the distance between them is x, so it is x square, that is equal to force due to 2q. It is again I will be writing k into 2q into q by 2x square, so I will be writing this as 4x square. Let us see what are going to get cancelled. X square, okay, then that q must be what? Small q by 2. And what could be its nature? Its nature could be minus or plus? Nature, yes, okay, it could be minus q by 2. Next question they asked in worksheet 3, that is based on electric field. That is based on electric field. Electric field. Let us see what are the doubts the students asked. So in that, the first question they asked is question number 9. Question number 9. So it is given that the question is, two similar charges of same magnitude q are placed at a distance d apart. Q and another q, they are placed d apart, similar charges. The intensity of electric field at a point midway between the charges, midway between the charges, at the midpoint, means if this distance is x and this also x, what is that? Intensity of electric field, E will be how much it is asking. It's very simple, E will be 0. How? Let us see that. Here first thing is q1 is equal to q2 is given, right? So at midpoint, let us take that point here. What will be the intensity of electric field due to this one will be other side, E1, because the direction of E will be away from the positive charge and towards for the negative charge, right? So this is, or else if you imagine a test charge here, test charge is positive, so this is a positive positive repel each other, force will be in this direction, this also I will be taking in this. Here this will be away from that also E2. Here E1 is equal to E2. How? The magnitude of charges are same and the distances are same. If you calculate E value, will be k into q by r square, x square. E2 will be k into q by x square. Both are equal and acting in opposite direction, so that E will be 0. Clear? The next question is question number 11 from the same worksheet. The question is, two charges 8 microcoulomb and 2 microcoulomb are placed 10 centimeter apart. So this is, let us take 8 microcoulomb and this is 2 microcoulomb, both are placed at a distance of 10 centimeter. The intensity of electric field is 0. The intensity of electric field should be 0 at a point is dash, means at what point the intensity of electric field is 0. So listen carefully, as these two are positive charges, if I place any test charge here, for example, on the test charge the intensity of electric field will be in the opposite direction. Yes, as these two are positive, means let me explain. So if q1 and q2 are the same charges, same kind of charges, nature is same, then the intensity of electric field may be 0 in between the charges, in between the line joining the charges. Okay, what if they are unlike charges? Let us take, for example, this is minus q1 and this is plus q2, right? So in between the at any point in between the point, the intensity of electric field will not be 0. Why? Suppose you assume that a point here, due to q1, what will be the direction of E? This is okay, E1. Due to q2, what is the direction of E? That will be also in this direction. It is not 0. That's why when the charges are unlike, right, the intensity of electric field will be out of the charges. It can be away from the q2 or it can be away from the q1. Then which we should take, away from the q2 or away from the q1? So simple. Here you compare both the charges. If q1 is less than q2, right, then q1 is the small charge, then towards the small charge will be the point where the effective electrical intensity will be 0. Clear? So if q2 is the smaller, towards the q2. Clear this point? Right. Now in this case both are positive, so that we don't have that problem. Between that only it will be 0. So let us take a point between 8 microcoulomb and 2 microcoulomb, some point. Okay, this I will be taking at a distance of x from the 8 microcoulomb. Then what will be this distance? This will be 10 minus x. Okay, at x the intensity of electric field due to 8 is this side this I am taking as E8, and due to 2 microcoulomb, this is this side, this is 2. The resultant of these two will be the intensity of electric field, that should be 0, right? That means both should be equal. Now let us see that due to 8, E8 is how much? K into 8 into 10 power minus 6 by x square, right? Next, E2 is how much? K into 2 into 10 power minus 6 by how much? 10 minus x whole square. When these two are equal, then at that point it will be 0, E value. Therefore, compare these two, E8 is equal to E2, right? Then K into 8 into 10 power minus 6 by x square is equal to K into 2 into 10 power minus 6 by 10 minus x whole square. Now simplify that. 2 4s, 10 power 6 and 10 power 6. Okay, so 4 by x square is equal to 1 by 10 minus x whole square, right? This can be written as 4 is equal to x by 10 minus x whole square. From this, x by 10 minus x is equal to 2, right? Okay, then x is equal to 20 minus 2x. Then from this, what? X is equal to 10 by 3 centimeters. Okay, so that means at a point of 10 by 3 centimeters from 8 microcoulomb charge, the net field will be 0. Clear? In this way one can calculate if both are positive charges. If one is positive and negative, the point will be outside of that, not in between that. So towards which one you should take, depending on this relation, magnitude of which one is small charge. Okay, from that small charge you move. Right, next question the students asked in this same worksheet is question number 22. See that two charges of 10 microcoulomb and minus 90 microcoulomb are separated by a distance of 24 centimeters. Okay, one is 10 microcoulomb, next one is minus 90 microcoulomb, separated by a distance of 24 centimeters. Then electrostatic field strength from the smaller charge is 0 at a distance of. From smaller charge, at what distance the field strength will be 0, it is asking. Let us take that point will be here at a distance of x. Previously I said, okay, from smaller charge you take that point. Okay, not towards the large charge. Okay, this one again. So here the electric field due to 10 microcoulomb should be equal to the electric field due to 90 microcoulomb. So that means E90 should be equal to E10. Can you do it now? Right, simply it is K into 90 into 10 power minus 6 by 24 plus x square, that is E10 is K into 10 into 10 power minus 6 by x square. Now you solve as we have solved in the previous case. Okay, next question 23. 23, two electric charges 10 power minus 9 coulomb and 10 power minus 9 coulomb are placed at the corners of A and B of an equilateral triangle ABC of side 5 centimeter. Let us take an equilateral triangle ABC. At A the charge is 10 power minus 9 coulomb and at B it is minus 10 power minus 9 coulomb is placed. Okay, it is given that it is also 5 centimeter and 5 centimeter. The electric intensity at C, here we need to calculate. Similar problem in electrostatic force we have calculated. Same, Okay, at C, what are the directions of E values? Let us calculate. This is a positive and a test positive charge is placed, so that E due to A will be this side. This is negative and test charge is positive, E will be this side, EB. Okay, now what is the angle between them? This is EB and this is EA, and angle between them is 120 degrees. Now E will be what? Vector sum of E1 and E2. Then one can calculate E value as a root over E1 square plus E2 square, here EA plus EB. Okay, root over EA square plus EB square plus 2EA EB cos 120 degrees. Cos 120 value how much? Minus half. Cos 120 degrees is minus 1 by 2. You substitute the values and solve it. EA value how much? You take K into 10 power minus 9 by 5 into 10 power minus 2 whole square. Okay, EB value how much? K into 10 power minus 9 by 5 into 10 power minus 2 whole square. Okay, similarly you solve it. Right, in the same worksheet, next problem is 32. 4 point charges plus Q, minus Q, minus Q are placed at the corners A, B, C, D of a square of side A respectively. Let's take, this is a square of side A, and this is capital A, and this is a capital B, C, D. At A the charge is plus Q, at B plus Q, at C minus Q, at D minus Q, sir. Okay, so at what point on the line joining the intensity of electric field at the center of the square is at the center of the square. Okay, the thing what we need to calculate first is from the vertices what is the distance of the center. Okay, as it is A, the diagonal will be how much? A root 2, and half of it is will be A root 2 by 2. That is the distance, means R will be how much? A root 2 by 2. Okay, at here what are the directions of E values? Due to A is a positive, it will be away from that. This is due to EA. And due to B it is positive, so that it also away from that, EB. Due to C it is negative, it is towards that, so this is EC. And here also negative, so that it will be ED. Means at the center this is EB and this is ED, EA and EC. So the net electric field is vector sum of EA, EB, EC, ED. Okay, now one can calculate EA, EB, EB, EC, ED values. All are equal. Let us see EA. EA is K into Q by A root 2 by 2 whole square. EB also will be same, EC also, ED also will be same, because charge is Q, Q, Q and distance is same. Okay, first EA and EC value how much? Both are in the same direction, so that EA and EC, EA plus EC, how much? 2 into K into Q by A root 2 by 2 whole square, 1 plus 1, 2. Similarly EB plus ED, EB plus ED is 2 into K Q by A root 2 by 2 whole square. Okay, now this is one and this is another one. Now what is the angle between them? 90 degrees. Now finally E will be equal to what? This whole square plus this whole square plus 2 into this one into cos 90. Cos 90 is 0. Therefore directly you will be getting E as a magnitude root over 2 into KQ by a root 2 by 2 whole square plus 2 into k cube by a root 2 by 2 whole square. This is, if you simplify that, you will be getting the answer. The answer is 4 root 2 k cube by a square. Okay, these are the doubts expressed by the students. So I think you satisfied with these solutions, right? Thank you. Many of the students still did not subscribe our channel. Subscribe. When you subscribe, a bell symbol will come, that you click on the bell symbol and share the videos to your friends and like the videos. Okay, thank you very much.